This is a brief tutorial on the molar mass of compounds, and we'll do a little bit of moles, molecules, grams type calculations. If you need a little bit more detailed description on that, look at my moles video and it'll show you how to work through some of those calculations, but we'll focus on elements, where this presentation focuses on compounds. So what's molar mass of a compound? Molar mass of a compound is the mass of exactly 6.022 times 10 to the 23rd molecules, formula units, so on and so forth, typically expressed in grams per mole. Adding up the molar mass for a compound is simply the sum of the molar masses or the atomic masses of each of the elements contained in the compound. So, for example, let's say we have a diatomic element like chlorine gas, Cl2. The molar mass would just be 2 times the atomic mass of chlorine, or 2 times 35.45 grams per mole, or 70.90 grams per mole. Let's add up the molar mass of propane, C3H8. So it's going to be 3 times the mass of a carbon plus 8 times the mass of a hydrogen. So we have 3 times 12.01 grams per mole plus 8 times 1.01 grams per mole. We get 44.11 grams per mole for propane. This is a schematic that was in my previous video on moles, where we can go from atoms or molecules to moles and then to grams, or vice versa. Use Avogadro's number to go from atoms or molecules to moles. We can go from moles to molecules, we multiply by Avogadro's number. Go from molecules to moles, we divide by Avogadro's number. We use molar mass to go between moles and grams. Multiply by molar mass to go from moles to grams. Divide by molar mass to go from grams to moles. However, that is not allowed. We cannot go directly between atoms and molecules to grams, or vice versa. We have to go through moles. So look at an example. What's the number of moles of lead to nitrate and 23.6 grams of lead to nitrate, which is PbNO32. So what we need to do is add up the molar mass of lead nitrate, because we'll need it to go between grams and moles. So we'll have a mass of a lead plus 2 times the mass of a nitrogen plus 6 times the mass of an oxygen. So 207.19 grams per mole plus 2 times 14.01 grams per mole plus 6 times 16.00 grams per mole. And we find that lead 2 nitrate has a molar mass of 331.19 grams per mole. Now we can do the calculation. Start with 23.6 grams of lead nitrate. Divide by our newly calculated molar mass, 331.19 per 1 mole. We find that we get 0.0713 moles of lead nitrate. So now we want to calculate the number of carbon atoms in 20 grams of propane, C3H8. We already previously calculated the molar mass of propane, so we won't do so again. We'll just use the result. Have 20 grams of propane. We're going to divide through by 44.11 grams per 1 mole. And then we have to realize that there are 3 moles of carbon atoms per 1 mole of propane, so that we can get to carbon atoms. And then use Avogadro's number to get the number of carbon atoms. When we run that through the calculator, we get 8.19 times 10 to the 23rd carbon atoms. Percent mass of compounds, we can also get a theoretical percent mass of a compound by using the molar mass. That percent composition will be the mass contribution of the individual element in the compound divided by the total mass of the compound multiplied by 100%. And if we just use molar mass, that will just be a theoretical percentage as opposed to an experimental percentage. But the percent mass will be the mass of the part divided by the mass of the whole times 100%. More theoretically, we could say the mass contribution of the element divided by the mass of the compound times 100%. So now we want to calculate the percent composition of carbon and hydrogen and propane. We already previously calculated the molar mass, so we won't do so again. Percent of carbon is going to be 3 times the atomic mass of carbon, 12.01 grams per mole, divided by molar mass of the compound, 44.11 grams per mole, times 100%. We get 81.68%. Percent for hydrogen, you could either subtract from 100 or do the calculation again, like above. We'll do the calculation like above. Just for practice, we got 8 times 1.01 grams per mole divided by 44.11 grams per mole times 100%. We get 18.3%. So within rounding error, we have the 100% if you add those two percents together. Had to truncate a little bit on the hydrogen percentage because of significant figures. This has been a brief tutorial on molar mass of compounds, grams, moles, molecule calculations for compounds, and percent by mass of compounds.